Boom! Yes, folks, Hume here again. In this video, we're going to pilot a new series. We're going to pilot a new topic. The topic that we're going to deal with in this series of videos is the topic of completing the square. Alright? That is a topic that is found in section 2 of the CSEC Math syllabus, and it is also found in section A in the Add Math syllabus. So in other words, this is one of those topics that straddles both maths and add maths at the CSEC in terms of the CSEC syllabus. Syllabus, syllabi, whatever. Syllabuses, syllabi. I think syllabi is the plural of syllabus. Right? Double check that for your English. So we're moving forward. One note before we continue. We will not, in this video or in this series of videos, be just dropping a formula and saying, hey, go and learn that. We're not doing that at all. That option is always there, but even if you choose to pursue that option, if you're coming through me in any way, shape, or form where this topic is concerned, we're taking a long route. We're going to go through it from a perspective of understanding. Understanding what we're doing, breaking it down, so that whenever you have to engage with this thing, you can engage with it from a perspective of knowledge, from a perspective of competence, from a perspective of knowing that you know what to do, as opposed to scrambling to remember a formula. No partner. Or worse yet, you have the formula committed to memory, but you don't understand it. And if they make any slight deviation in terms of what you're accustomed to, you're not in a position to think things out on your own and figure it out. Alright? And that is one of the reasons why we're doing this in a series of videos. I'll be breaking it up step by step so that you have the opportunity along the way to take it in small bite-sized chunks and digest it as you go along. So let me start. Completing the square basically is one thing. Right? The thing that it is pretty straightforward. But like so many things out here, how you get from point A to point B is where the things start to get nice. Alright? So when we complete in the square, we basically essentially converting the quadratic expression from one form to the next. So we have this form. This is the ax squared plus bx plus c. And then we have this form. You have a into x plus h squared plus some constant k. So in this form, h is a constant, k is a constant. Right? Let us see. This k is not to be confused with this c. Two different constants, right? The fact that they are denoted by two different letters should make life a little easier. Yes, this a is the same thing as this a, and you will see that later on as we go along. But that is just some basic stuff that you can remember for now. This is what we refer to as the standard form. Right? The standard form of the quadratic expression. This is the form that most CSEC students would be familiar with. Ax squared plus bx plus c, where a is some constant, b is some constant, and c is some constant, and x is the variable under consideration. This here, is what we refer to as the vertex form. Right? And the reason why they refer to it as the vertex form will become apparent a little later when we start to get into dealing with expressing these things as a graph. Alright? But later for that. Alright, so that is the fundamental thing. Right? We're moving from standard form to vertex form. That is what it is you're doing when you're doing what we refer to as completing the square. However, the trick, the underlying aspect of this whole thing lies here. This guy here, x plus h to be squared. This is what everything revolves around. And if you're comfortable with this and you understand what we're going to do with this now, then you're well on your way to being proficient in completing the square. The only thing that you will need to be able to do after that is to add and subtract and multiply fractions to be able to deal with squares and square roots. And of course, as always, to be able to manipulate your minus signs. Alright? But again, we will deal with that further down the road. Let us concentrate on where we are at right now. So let us continue here by just taking a little time to deal with this fella here. Again, we just slow down a little bit. We slowing down a little bit. Right? We taking a little time to just kind of stir the pot a little bit before we start to shoot off again. So that anybody who needs to revise particular things, you have the opportunity to say, well, alright, I need to go back and do this. I could go back and do it, because going forward, if you're wobbly in this little thing that we're going to do now, you'll have problems. Alright? So look at that, x plus h all to be squared. Alright? Now, x plus h to be squared is the same thing as x plus h into x plus h, right? We know that. And if we have to expand this now, this is the algebraic expansion. Right? I have a whole video on that, but that's a different discussion. X here by this x is x squared, and then we take the x and multiply it by the h, and that will give us xh. So in other words, we multiply the x in this expression by each term in this expression, and then we repeat the procedure for h. So we take the h and we multiply it by x. That will be hx here, and we take plus h and multiply by plus h, and we get h squared. Now, we know that by the commutative law, xh and hx are one and the same. Alright, and if you're not sure what all this talk about commutative law is about, you could search it, you could look it up, you could research, you could ask a question. But just by way of illustration, you know that 2 multiplied by 3 is 6. You also know that 3 multiplied by 2 is the same 6. You know that 2 plus 3 is 5. You also know that 3 plus 2 is 5. So in other words, the operations of multiplication and addition are what we refer to as commutative, right? As the commutative law, the topic of another discussion. So if xh is the same thing as hx, then we can write this over as x squared plus, let us see, we're going to write it as hx, right? X squared plus hx plus hx plus h squared, right? Which will be x squared plus 2hx plus h squared. So x plus h to be squared is equal to this. Now, of course, some people may recognize that we could have gone from here straight to here in one shot. There's a particular relationship that it is very good to have committed to memory, and that relationship, if I can squeeze it in the corner here, is the relationship where we know that a plus b squared is equal to a squared plus 2ab plus b squared, right? And the negative counterpart is the same, where we know that a minus b squared is the same thing as a squared minus 2ab plus b squared. In other words, it is always helpful to have these two relationships committed to memory, because it will make your life a lot easier. It will save you a lot of time in exams, both in maths and in advanced maths. However, if for some reason you forget that a minus b squared is this, or you forget that a plus b squared is this, or you're not sure for some reason, you have the ability here now, by simply going through the process, you could get the answer. So in other words, if you can't move from here to here in one shot, you could go through the procedure and get from here to here. Alright? So don't worry about this too much if you're not too familiar with it, just understand that if you have to square an expression that looks like this, you could go through the whole procedure here. Remembering, most importantly, when in the middle here, that the two expressions here are one and the same due to the commutative property where the order of multiplication doesn't matter, the answer is the same. And because of that, we could express them as one expression here, and then we have 2x each in the bottom here. So that is the situation for the plus. We're going to do the same thing now for the minus. So we had x plus h squared, and now we're going to deal with x minus h squared. Right? So watch it. X minus h squared. Right. X minus h all to be squared is the same thing as x minus h into x minus h. Again, we're going to the procedure. X by x is x squared. X multiplied by minus h is minus xh. Minus h by x is minus hx. And minus h by minus h is plus h squared. Good? We just kind of take some things for granted here in terms of knowing that a negative by a negative is a positive. We also have to remember that if we're dealing with this h, we're dealing with this h as a minus h and not h. Same thing with this minus h on this side. Of course, again, because of the commutative property, we know that xh is the same thing as hx. So we could write this over as x squared minus hx minus hx plus h squared. And this now would evolve into x squared minus 2hx plus h squared. And again, because of this relation, if we had used this relationship where a minus b, this is normally how we teach it, this is normally how we learn it, right, using the letters a and b, where a minus b all to be squared is a squared minus 2ab plus b squared. If we substitute x here for the a over here and h here for the b over here, then we can say, watch it now, we can say that, change the color of the ink, we could say that x minus h all to be squared would be, watch it, x squared minus 2, remember this is the x and this is the h here, right? 2 by, well, xh plus h squared. And if we know that xh is the same thing as hx, we could write this over as x squared minus 2hx plus h squared. Alright? So we can use this particular relationship to get from here straight to here in one shot. Or, if need be, you start from the top and you go through a couple of steps and you get to the same point. So in other words, it doesn't matter if you take the direct route of memory or if you take the route of developing the thing as you go along. So long as you get the same answer, that is all that matters. Of course, in an exam environment, you have the added pressure of time. So that is where your own preparation would come into play. That is the subject of another video. So these are the two relations that we have to remember when we're going forward with this topic of completing the square. Alright? So I'm going to clear the board and just write them over, and that will bring the first video to a conclusion. And then in the following videos, we're going to do some examples and start to get into the meat of the thing now. Alright? So just to recap, right? Completing the square essentially is the process of moving from the standard form to the vertex form. And if you could remember that x plus h to be squared is x squared plus 2hx plus h squared, and x minus h to be squared is equal to x squared minus 2hx plus h squared. This right here is the foundation for completing this square. And that right there is where we're going to end this video. And we're going to start the video by picking up where we left off here and moving forward. Alright? So stay tuned, look out for the next video, and let us get this thing done once and for all.